Alrighty, 6.2, factoring trinomials. Trinomials specifically. So last section we talked about greatest common factor and factoring by grouping. Greatest common factor works for any size, anywhere, anytime, okay? So any size polynomial you want. Binomial, trinomial, 4 terms, 8 terms, 100 terms, right? Because it basically boils down to what do they have in common, right? It doesn't matter. It doesn't matter how many there are. It's just what they have in common. Trinomials, then we talked about grouping, which was specifically for 4 terms. So grouping is specifically for 4 terms. Otherwise, you can't make the 2 equal groups, right? Today, we're going to talk about the case in between. So we got trinomials. Trinomials, remember, that means 3 terms. So they look like this. Excuse me. They look like this, ax squared plus bx plus c. Now, a, b, and c are just numbers, right? So we're not going to see things like ax squared plus bx plus c, but you might see things like, you might see things like this, x squared plus 8x plus 15. So those are the trinomials that we will be looking at today. Okay, first where a is just equal to 1, and then where a is not equal to 1. Before we get there, though, let's remind ourselves how multiplication of polynomials works. So let's go back to this beginning here. We've got x plus 3 times x plus 5, right? And recall I said there's a multitude of organizational ways you could do this, but what it boils down to is distribution property, right? Every pair has to get multiplied. Insides and ends, right? So the first ones have to be multiplied. So you first want to multiply x times x and then x times 5. Then you want to multiply 3 times x and 3 times 5. So you eventually get this string of 1, 2, 3, 4 of them, right? If you have a binomial and a binomial, you end up with 4 terms. Then you simplify what you can. And these two guys are like terms. So combine like terms, you end up with this trinomial, right? That's all from last chapter. And it's very, very important to remember those steps because factoring is doing those exact same steps backwards. That's all we're going to do. We're going to take stuff like this. We're going to break apart that like term, right, into something that when we do that, then we can factor by grouping. And we get back here. So we're just going backwards from left to right now. Okay, so it's going to be the exact same thing. Once again, there are like 400 different organizational methods to this. If you want to set it up in the box, or you want to set up FOIL, or you want to set up whatever you want, that's totally fine. Excuse me. I will be just doing it with the distribution property. Okay, that's all I'm going to do. I'm not going to set up a big X or a table or anything like that. If you already know those methods, please use them. Don't think that you have to learn another different method, okay? It's all the same thing, but it's distribution property backwards. So I'm going to just go ahead and jump down here. There are steps on how to solve it here if you don't have an organizational method already. Then you can follow these steps, or you can follow what I do in the video. It's the exact same thing. But once again, usually things are much easier to see when you have actual numbers there. So I'm going to just go ahead and do one on the first problem. So let's try the first problem. We have y squared plus 2y minus 35. This works for any variable. It does not have to be x. Works at, it works for z squared plus z minus 35, right? The only thing you want is this standard quadratic form, the y squared. So the squared, the single, then the constant, right? That's what you want. You want a square, a single, a constant. All right. Now, when I was multiplying, my second step, or my last step, was to take this stuff and combine like terms. So what I want to do now is I want to uncombine like terms. That's what I'm going to do. I want to take this guy, I want to uncombine him into 2 things that add together to get 2. Okay? Now, they have to be a very specific 2 things. So I'm going to play a little game. I'm going to play this game. It starts with identifying A, B, and C. Okay, so just like up here, there was an A, a B, and a C, and it's basically just a spot number. Okay, it's a coefficient that I want to identify. Well, here I can see that A is equal to 1, right, because there's nothing in front of that squared. B is going to be equal to 2. That's what's sitting in front of the single, or y to the first, I should say. And then C is negative 35. That's what the constant is. Okay, so that's the first part of the game. Identify those 3 numbers. Now, this is the meaty part of the game. The big part of the game is I want to find 2 numbers, any 2 numbers I know, that multiply to A times C, or in this case, 1 times negative 35, so negative 35, and that add to B, or add to 2. So for this specific polynomial, the game is what 2 numbers multiply to negative 35 and add to 2. Well, that's a little tricky. Let's take a look at the factors of 35, right? Because these two numbers have to multiply to negative 35. So let's look at some things that multiply to negative 35. Well, negative 5 and 7 do, as well as 5 and negative 7, right? And then also negative 1 and 35, and 1 and negative 35. Those are all the things that multiply together to get negative 35. Now, which one of them adds to positive 2? That would be this first one. I found my magic numbers. Okay, that's what I like to call them, the magic numbers. That is by no means an actual mathematical term. But those are the two numbers that I now need to split, I need to uncombine like terms with. Okay, so that's how you play the game. What multiplies to A times C and adds to B. Cool. I'm going to do the rest of the problem over here. So here was my original polynomial, y squared plus 2y minus 35, right? That's my last step when multiplying. Now I'm going to go back a step. I'm going to take this and I'm going to uncombine like terms with those two numbers I just found. So instead of y squared plus 2y minus 35, I'm going to have y squared plus 7y minus 5y minus 35. And notice, if I wanted to go back a step, all I'd have to do is combine these like terms, right? Combine those like terms and I would get back to where I started. So that's what I'm doing. I used those numbers to undo that step in the multiplication process. Because factoring is just undoing multiplication. The reason I wanted to do that is because now I can factor by grouping. I have 4 terms with some things in common. So I will set up 2 groups. Here, these guys have a y in common. What's left over is y plus 7. Here, they have a negative 5 in common. So what's left over, take out the negative 5, is y plus 7. And remember, factoring by grouping is just grouping 3 times. So I grouped once, twice, now I'll group again, y plus 7. And I'm left with y minus 5. And I have officially factored this trinomial, right? I've got 2 binomials, both of which are prime, right? Both of which are prime. And if I multiply them, I would get back to this thing. So I factored. That's basically it. Play the game to find those numbers, uncombine like terms, factor by grouping. That's it. That's all it is. Let's do it again. Alright, start by playing the game. Now, there are quite a few examples in here. I may not do all of them because this is just a supplement video. We will do all of them in class, but if you need, so I'm going to leave a few of them blank, but mainly if they're extra practice. If you need to do these as extra practice, you want to make sure you're getting it, then try out those ones, okay? But for now, I'm just going to pick and choose like 5 or 6. Okay, so x squared plus x minus 72. Well, first I'll identify A, B, and C. A here is still equal to 1, and it looks like B is also equal to 1, and C is equal to negative 72. Fabulous. Sweet, 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 right? Next, I will try to find 2 numbers that multiply to A times C. Well, A times C is going to be 1 times negative 72, or negative 72, right? So negative 72. And add to B, which is 1, right? So really I'm looking for 2 things that multiply to this and add to that. Multiply this, add to that. Well, that could be tricky. Let's look at all the factors of negative 72. Got negative 1 and 72. I've got 1 and negative 72. Okay, nope, not really working there. 2 and, well, it's even, so I know it divides by 2. 36. So negative, no, versus 2 and negative 36. No, that's going to be negative 34. That's not 1, right? Keep going. Notice I'm just looking at them one by one, right? You're more than welcome to find all of them, but if you look at them as you go, you don't have to, find all of them. Let's see, 72 divided by 3, 24. That one is a factor. If I make the first one negative, that's positive 21. Make the second one negative, that's negative 21. Neither one of those is equal to 1, right? So it looks like it's neither one of those. Let's see, 72 divided by 4, that's 18. Make the first one negative, that's negative 14. Make the second one negative, that's make the first one negative, that's positive 14. Make the second one negative, that's negative 14. So neither one of those. It's not a 0, so I know it's not divisible by 5. 72 would be 6 and 12. Getting there. 6 and, no, neither one of those. 6 or negative 6? Nope. Alright, 7, no. 8 and 9. Make the first one negative. Ah, I found it. 8 times negative, or negative 8 times 9 would be negative 72. Negative 8 plus 9 would be positive 1. Oops. So yes, sometimes it takes... Alrighty, so yes, sometimes it takes a minute. If you can see it right off the bat, then by all means, please jump to it. But if not, then just go through the factors of 72 until you find it. Totally fine. Alright, let's finish out this problem. Now that I found the numbers, I can unmultiply. I can factor. So start with x squared plus x minus 72, right? And the whole point of playing this game over here was to separate that x into like terms, right? So we've got x squared, n stays the same. Now instead of x, I have negative 8x's and 9x's. So those two numbers become my middle numbers. And then still minus 72. And from here, I factor by grouping. This in front here has an x in common. I'm left with x minus 8. Over here, they have a 9 in common. I'm left with x minus 8, which is good. That means they matched up. If I didn't choose the right magic numbers, then those wouldn't match up, right? Those would end up falling apart. I wouldn't be able to group if I didn't choose the right numbers. And from here, we've got x minus 8 and x plus 9 as my final factored form. I know that because they are both prime, right? They're both prime. Alrighty, looking good. So that's how you play the game. That's how you play the game. Let's do the next one. Let's do the next one. Might as well. I might do all of these. I might take back what I said earlier about not doing all of them. Because these are actually fun for me. Okay, so here we go. I got t squared plus 14t plus 48, right? So I need two numbers. Well, let's first identify. A is 1, B is 14, C is 48. No negatives this time. Okay, doesn't matter. Let's play the game. A times C is going to be positive 48, and B is going to be 14. Cool. So I need two numbers, multiply to 48, and add to 14. Now you may already see them, right? You may already see them. But if I don't, then I'm just going to start with 1 and 48. Nope, that adds up to 49. Negative 1 and negative 48. Yes, I'm still considering negatives because two negatives would make a positive, right? That would add to negative 49. Okay, neither one of those. Let's see, it's even. So 2 and 24, or negative 2 and negative 24. 26 and negative 26? Nope. Neither one of those is 14. Let's see, 3. Does 48 go into 3? I believe it does. It does. It's 3 and 16. And negative 3 and negative 16. Ooh, 16 and 3. Oh, those add to 19 and negative 19. So close, but not quite. Okay, 4 and 12. Or negative 4 and negative 12. That would be 16 and negative 16. Oh, I'm so close to 14. It must be the next one. Okay, 5 can't be 5 because it's not a 5 or 0. But 6 and 8. Oh, there it is. 6 and 8. 6 and 8 add to 14. Fabulous. Alright, let's go ahead and use those magic numbers to factor. So I've got t squared plus 14t plus 48, right? And the whole point is to get these two guys to break up. So the first one stays the same. I can put them in either order, by the way. I could definitely put 8 first or 6 first. Either one would be fine. As long as I choose the right numbers, should work out the same way. So 6t plus 8t, and then I'll keep the constant the same, 48. Now I will factor by grouping. Group the first two, group the second two. And here I will take out a t. I get t plus 6. Over here I will take out an 8. I get t plus 8. And now I have, oops, no I don't, I have t plus 6. 48 divided by 8 is not 8, Miss K, that's silly. Alright, and I get t plus 8 and t plus 6 as my final factored form. Sweet. Alrighty, hopefully this is starting to make sense, right? The game is starting to make sense as it goes along. I'm just going to keep going. M squared plus 6m plus 7. So A is equal to 1, B is equal to 6, C is equal to 7. Right? 1, 6, and 7. So I need two things that multiply to 1 times 7 or 7 and add to 6. Ooh, interesting. Interesting, interesting. Let's see. Things that multiply to 7 and add to 6. Well, let's take a look at the things that multiply to 7. There's 1 and 7, and -1 and -7. Okay? Well, that adds to 8, that adds to -8, so not that one. Uh-oh, I've run out of factors. Interesting, interesting. What do I do from here? This polynomial has now failed the game. There are no magic numbers that I can split it up. Sometimes that happens. This is what we call prime, meaning the only factors are one in itself, right? We talked about these before a little bit in GCF, right? And I should double check that there's no GCF. There isn't. But it doesn't work. It didn't work with the game. It's not 4 terms, so I can't group. There's no GCF. This is a prime polynomial. They rarely come about, but they do come about. So watch out for those. Sometimes it doesn't work. And this looked like it kind of would work, right? It looked like 6 and 7 may have something that would multiply and add, right? They're very, very close to each other. But it didn't end up working out. Sometimes that happens. Let's try the next one. Ooh, I've got 2 variables this time. Don't panic. Don't panic. Remember, all we're concerned with is A, B, and C, right? That's how we play the game. Hopefully that doesn't mess up our grouping, but we've seen stuff like this before that it didn't. So let's just play the game and see what happens. A is equal to 1, B is equal to 6, and C is equal to -16. So notice that, yes, C is not the constant in this case, but I'm setting it up as such. A, B, C, right? I actually could play it backwards too, but just so your minds don't explode, we're going to go in the same order, okay? So A, B, and C. So now I need 2 things that multiply to A times C, -16, and add to B, which is 6. Interesting. Okay, well the things that multiply to 16 or -16 are -1 and 16, or 1 and -16. 15 and -15, nope, neither one of those add to 6. Next we've got 2 and 8, or sorry, not 2 and 8, -2 and -8. -2 and 8, and then -2 and -8. Sorry, one of them has to be negative to get negative. Let's see, this one, ooh, there we go. That one adds to +6. Found them. Alrighty, so we found our magic numbers. Let's go ahead and factor. I have p squared plus 6ap minus 16a squared. And I'm doing the exact same thing, right? Remember when we did it up here, we broke up that middle term. So let's just break up that middle term into minus 2ap plus 8ap. Notice it gets the exact same variables every single time. If it's a t in the middle, it gets a t. Each one of them gets a t. If it's an ap in the middle, each one of them gets an ap. And then I still have a minus 16a squared at the end. Okay, now we'll factor by grouping, as we've done before. Because we're unmultiplying, right? We're just undoing the multiplication. Here, these guys have a p in common. I'm left with p minus 2a. Over here, these guys seem to have an 8 in common, an 8a, pardon me, in common. So I'm left with p minus 2a. And they match. Fabulous. So it looks like p plus 8a times p minus 2a, right? These areas are the same. They become one. The bits become the other. And I found my factored form. Fabulous. So even with multiple variables, it ends up being the same thing, right? It ends up being the same process. Play the game, separate that middle term. That's all you're doing. You're unmultiplying. You're using seals you already know how to do, multiplying polynomials, and you're just doing them backwards. That's literally all you're doing. Alrighty. Last one before we get to a not equal to 1. Notice something's different here. Something's very different here. Very different. Couple things different. That's not even a quadratic. Right? We are factoring trinomials of the form ax squared. And that's a problem because this is a cubed. But what should I always start with? What's the first thing I should start with? Hint, I've underlined all 3 terms because they have a GCF. So let's start with a GCF. What do they have in common? Well, they have a y in everything, right? They also have a 16 in everything, right? 48 divided by 16, whole number. 32 divided by 16, whole number. So let's go ahead and take out a 16 as well. We're left with y squared minus 2y minus 3. And I started with the GCF. Good. Now let's see if we can factor this trinomial using factoring trinomials, right? We can't use grouping, obviously, because it's not 4 terms, right? Maybe we'll use grouping when we factor trinomials, but we're going to try, can't use it just straight from the get-go. Gotta try playing the game. All right, 2 things. First off, a is equal to 1, b is equal to -2, and c is equal to -3. So I need 2 things that multiply to a times c, that's -3, and add to b, which is -2. Let's see, 2 things that do that. Well, I've got -1 and 3. That adds to +2, and oops, +1 and -3. Ah, that adds to -2. Sweet. So I can take y squared minus 2y minus 3 and split it up into y squared plus y minus 3y minus 3. Factor that by grouping. I'm running out of room here, but that's okay. And I end up getting y plus 1 and y minus 3. Sorry. Y plus 1 and y minus 3. Now I got to be careful though, because that was the factored form of this polynomial, right? And that wasn't our polynomial. We want a factored form of that. So I actually have to drag and drop my 16y as well. Just like we did when we were doing GCF and we had those extra things in front, right? You have to just drag and drop them. They don't really add too many steps, but we got to make sure we don't forget them in the process. So my actual final factored form is 16y times y plus 1 times y minus 3. I notice everything is prime, so I'm finally done. Sweet. So sometimes you have a GCF in front. That's the only thing different about this problem. Otherwise, it was the exact same process. Alrighty, let's talk about example number 2, a not equal to 1. You may think, oh my gosh, whole nother thing, right? Nope, exactly the same. The only reason these are usually broken into 2 pieces is because of a pattern we're going to talk about later. But let's just do the exact same game, right? Exact same game. This time a is not equal to 1. So I've got 12r squared minus 5r minus 2. A is equal to 12, b is equal to -5, and c is equal to -2. Okay, I need to find 2 things that multiply to a times c. Here's where the difference is happening. Notice up until now, a has always been equal to 1, so a times c is just the same thing as c, right? Just because it's been multiplying that way. This time it's not. 12 times -2 is -24. Okay, I mean, it's really not that big a difference, right? But that's really the only thing that's changed. And then b is -5, so we need 2 numbers that multiply to this and add to that. Coolio. Let's take a look at it. Well, 24, we've got -1 and 24. That's -23, so probably not that. 1 and -24 would be -23. Nope, okay, that's not -5. 2 and 12, that would be -10. Nope, +10, and then -10. Notice I'm adding as I go. 3 and 8. Ooh, that would be +5. That's +5. Ah, I found it. -8 and 3. Those multiply to -24 and add to -5. Multiply to 24, multiply to -24 and add to -5. Okay, so now we'll factor. Now we'll factor. Let's uncombine like terms. Notice I'm not even like really explaining this all because it's the same thing, right? It's the exact same thing we've done in 5 problems. So I'm just going to do it again. Original polynomial, 12r squared minus 5r minus 2. I'm going to split up the middle term, right, into -8 and 3. So 12r squared minus 8r plus 3r minus 2. Again, it didn't matter if I put the 3 first or the 3 second. It doesn't matter. I'll factor by grouping. Here I've got 12 and 8. What do they have in common? They have a 4 in common, and they also have an r in common, right? So 4r, and then I'm left with 3r minus 2. Over here, those guys don't have anything in common except what? They have a 1 in common. Okay, so good. Just like last time, they have a 1 in common. So I can take out the 1. We've seen an example of this before, right? We've seen an example of that. Not a big deal. Just take out a GCF of 1. These 2 guys match. I have 3r minus 2 times 4r plus 1. And I'm done. Ta-da! Cool. Alrighty, So that's the exact same thing for the next like 12 problems. So I'm only going to do a couple of them, but I want to notice you to know something first. You may, as we've been working on in the last a equals 1 problems, in the last section, you may have noticed a similarity between what you got as a magic number, magic numbers, and what you got in your factors. You may have noticed that they ended up being the same, right? If we had negative 5 and 7, we got x plus 7, x minus 5, right? If we had negative 8 and 9, we got x minus 8, x plus 9. And I know that some people are going to take that as a shortcut, which is fine, okay? That is okay. However, it's only a shortcut for a equal to 1, okay? If a does not equal 1, that shortcut does not work. Because you'll notice in this problem, we got 3 and negative 8, and nowhere in our answer was a negative 8, right? So it only applies to a equal to 1. If you're not going to remember the a equals 1 part, don't remember the trick, okay? Just don't even think about it. Ignore what I am saying right now and just play the game, okay? Play the game, factor by grouping. It is a coincidence, well, not a coincidence, it's because a equals 1 that works. If it's not equal to 1, it doesn't work, so you can't use it, okay? All right, let's factor each, yeah, try it. Let's do another one, let's do B. All right, so I've got a is equal to 3, B is equal to 7, C is equal to 2, right? A, B, C. Bang, bang, bang. A times C, this time it's equal to 6. B is equal to 7. Now you may be thinking, oh, we already know this one doesn't work, ha ha ha. Be careful. Last time A times C was 7 and B was 6. It was flipped, so this one may actually work. Let's look at the things that will multiply to 6. We have 1 and 6. Oh, and those add to 7. Cool, that was really fast. So now we'll take our original polynomial, 3x squared plus 7x plus 2. A is not equal to 1, so I know that this does not factor down to x plus 1, x plus 6. Okay, it does not factor down to that. Instead, I'm just going to split up the middle. X cubed plus, let's do x plus 6x plus 2. So I broke up 7 into 1 and 6. 7 x's into 1x and 6 x's. Alrighty, now I will factor those out. Factor by grouping. Here, these guys just have an x in common. So I have 3x plus 1. These guys have a 3 in common. I'm sorry, a 2 in common. So I get, oh wait. What did I do? Yeah, they have a 2 in common. So I get 3x plus 1. Sorry, a little mental blurb there. And I end up getting matching ones, so factoring by grouping works, right? GCF once, GCF twice, GCF 3 times. X plus 1 and x plus 2. And notice, I had a 6 as a magic number. Nowhere in my answer did I end up getting a 6, right? So a pattern didn't work. I end up getting 3x plus 1, x plus 2. That is my final factored form. I know that because they are both prime. Alrighty, I'm going to skip C, I'm going to skip D, and I'm going to head down to E, just because it's got 2 variables, okay? But if you're watching this at home, you think you need the extra practice, go ahead and do those. If this is class, we would have done both of those, but we're just not going to do it here. Alrighty, let's try out this one. 18m squared minus 19mx minus 12x squared. So again, just like when a equaled 1, it didn't matter, right? It didn't matter that there were 2 variables. All that matters is that we identify A, B, and C, and we play the game. Well, first off, is there a GCF here? No, there isn't, because 19 is prime, so that's okay. Maybe I could have made my life a little easier by finding a GCF across the board, but looks like I did. So here, 18 is A, negative 19 is B, and negative 12 is C. A times C is negative 216. And B is negative 19. Alrighty then. Maybe it's going to take a while, right? Let's look at the factors of 216. Divided by 2, 108. 108 and 2 are probably not going to add to negative 19. Divided by 3, 3 and 72, probably not going to add negative 19. Divided by 4, 4 and 54, not going to add to negative 19. Divided by 6, 6 and 36, getting closer, but not going to add to negative 19. Divided by 8, 8 and 27, ooh. Let's take a look at 8 and 27. Let's see, one of these has to be negative. Which one has to be negative in order to get negative 19? The 27. So, our magic numbers are 8 and negative 27. Notice we found them after like 30 seconds. I even did it with you. I didn't know this ahead of time. I didn't memorize all the factors of 216. I just started typing into the calculator, divide by 2, divide by 3, divide by 4, divide by 5, divide by 6, and then I found it, right? I just did mental calculations and I did it. You're welcome to write it down. It takes a lot of room, but you can write them all down if you need to. It just takes time. It's okay. All right, now I will take those magic numbers and I will use them to factor. My original one was 18m squared minus 19mx minus 12x squared. Now I'm splitting up that middle guy. So 18m squared minus 27mx. Why I put the 27 first? I don't know, I just chose to. 8mx minus 12x squared. Okay, now we will factor by grouping. Same thing as before. Start with this guy. 18 and 27, they both have a 3 in common. They both have a 9 in common. Looks like 9 is the biggest. So we'll do 9, and they both also have an m in common. I'm left over with 2m minus 3x. Cool. Here, 8 and 12 have a 4 in common and an x in common. And what's left over is a 2m minus 3x. Okay. And luckily they match, so my final factored form is 2m minus 3x plus 9, and whoops, can't drop the m, 9m plus 4x. Notice neither 8 nor 27 is anywhere in our answer, but that's okay, it's not supposed to be because 8 is not equal to 1. We got our final factored form though. 2 and 3 have nothing in common, 9 and 4 have nothing in common, so we are finally factored. Alrighty, hopefully this is starting to make sense, right? Starting to get to you, or starting to make sense across the board. Alrighty, let's do one more. Let's do G. G is another one of those cubics, right? We can't do things in cubics, right? So what do? We take out a GCF, right? Well, that's 16. They're all even, so I can take out a 2. Can I take out a 4? I think I can take out a 4. Yep, because they all divide by 4 too. Let's divide it by 4. And I end up with, okay, they don't have a y in common, so I can't do a y. But I get 4y cubed plus 6y minus 4. All right. Oops, 6y squared minus 4. And, oh, that didn't get rid of my problem. It's still a cubic. That sucks. Oh well, it happens, right? This is actually my final factored form. They have nothing else in common, right? It's not grouping, because it's not 4 terms. It's not trinomials, because it's not a square, right? Let me show you what would happen if we actually did try to do trinomials on this. But really, this is my final answer. If you have a cubic that you can't make go away, you're just done. But let's see why. Let's see why. Let's say I actually took this polynomial, 6y squared minus 4, and I tried to use the game on it. I tried to factor it like I have been before. So a times c would be 4 times negative 4, or negative 16. B would be 6, right? Two numbers that multiply to negative 16 add to 6. We kind of already found these. That would be 8 and negative 2, right? So 8 and negative 2. So I will try and factor this. 4y cubed plus 8y squared minus 2y squared minus 4. So I split up that middle term. Now I'll factor by grouping. When I do that, I've got, okay, here I've got 4 and y squared in common. I'm left with 4y plus 2. Over here, I've got a negative 2 in common. Got y squared plus 2, and therein lies the problem. Oops, I'm sorry, I don't have 4 here. Just kidding. I have y plus 2. But herein lies the problem. Notice in the first one I have a y plus 2, and in the second one I have a y squared plus 2. Those are not the same, so I can't GCF a third time, right? I can't GCF and take that out and get, what, y squared plus 2 or y plus 2, right? It wouldn't be the same. So that's where I have to stop. Breaks down. Boom, crash, burn, everybody dies, right? So that doesn't work for cubics. It only works for quadratics. And that shows you why, because the factoring by grouping falls apart. So instead, this is our final factored form. Awesome. Alrighty. Let's talk about one more thing today. Things that look like quadratics that we actually can do. So notice this is still sort of a quadratic because it goes up to a quadratic, right? So we can use kind of what we call a U substitution. And you got to stick with me on this because we're going to use it a lot later in chapter 9. So if you just want to think about this as a substitution, go for it. I'm going to take the letter U and I'm going to replace something. Let's call this a U sub first. And I'm going to take something horrible looking out and put in U. That's basically the idea. I'm going to take something horrible out and put in U. Question is what do I want to replace with U? Well, if I look at this closely, if I were to kind of cover this up and cover that up, that would look a lot like what we've already been working with. 2 times something squared plus 5 times something plus 2. If they happen to be the same something, which they do, x plus 3, then I can replace that with U. I'm just going to replace U is equal to x plus 3. Okay? So I'm going to do a variable substitution, just like we were learning in functions, right? You can change anything you want. You can take out an a, you can put in an x plus 4. You can take out a 9, you can put in a 3. Like, it doesn't really matter, right? Take out an x and you put in a 3. So now I'm going to take out the x plus 3, and I'm going to put in a u. 2u squared plus 5u plus 2. That's what I've done. I've just taken out the underlined parts and I put in u. I could put in a cupcake, I could put in a smiley face, I could put in the poop emoji, right? I could put whatever I want in there. This time I've chosen u, right? This is why it's called a u sub. So now I can factor this. This looks nice and easy, right? This is a is equal to 2, b is equal to 5, c is equal to 2. Let's see, a times c would be 4, and b is 5 still. So what two numbers multiply to 4 and add to 5? That would be 1 and 4. Now I can factor this guy, so I get, let's put it over here. Now let's put it over here. 2u squared plus 4u plus 1u plus 2, right? I split up the middle term into 4 and 1 and factor by grouping. Here I'm just doing the same thing over again, right? So 2u, u plus 2, and over here I've got just a 1, and u plus 2. So my factored form for the u part would be u plus 2 and 2u plus 1. Awesome. However, they didn't actually ask about u, they asked about x. So I'm going to do one little thing at the end. Since I took it out, I'm going to have to put it back in. So here in my factored form, u plus 2 and 2u plus 1, I'm going to now substitute it back in. So x plus 3 plus 2 and 2 times x plus 3 plus 1, right? So what was u? U was x plus 3. I've now put it back, right? I've now put it back. And then finally I end up with x plus 5. Let's see, 2 times x, 2 times 3, that's 2x plus 6 plus 1 would be 2x plus 7. And I'm done. So I managed to factor this horrible looking thing using something very simple that we've done 15 times now, and then just substituting that horrible thing back in, right? Cool. Let's try it again with this guy. Same kind of dealio. 6y to the 4th plus 7y squared minus 20. That's a quartic. That's what we call it, a quartic. It's a 4th degree polynomial, right? This one, you might think, okay, anything above a squared I can't do, right? I can't do. But again, we can use a u sub to make it a squared. If I remember from my exponent rules that y to the 4th is the same thing as y squared squared, then I can see what I need to make u, right? So I can change this to u is equal to y squared. And when I do that, 6y to the 4th becomes 6u squared plus 7u minus 20. In other words, whatever's sitting here, if this tends to look quadratic, if I can replace that middle variable with u and it works out so that I get a quadratic, then you want to use a u sub. You want to use a u sub. And I can solve this pretty easily. So a is equal to 6, b is equal to negative 20. So a times 6 is equal to, a times c is equal to, what am I doing? That's negative 120. And b is equal to 7. Okay. Two things to add to negative 120, multiply to negative 120 and add to 7. Let's see. Well, negative 120 divided by 2 is going to be like negative 60. Negative 120 divided by 3, 40. No, negative 120 divided by 4, that's 30. Negative 120 divided by 5, it's 24. Now, negative 120 divided by 6, we know that's 20. No, that ends up being, that's, sorry, 14, getting closer. So negative 120 divided by 8, 15, there we go. So it's, let's see, that would be, we want it to be positive, so 15 and negative 8. Took a minute, but we found it, right? 15 and negative 8. So now we can do our factoring. 6u squared, this time plus 15u minus 8u minus 20 instead of 7, right? Instead of 7, I've got 15 minus 8, which is the same thing. And we factor by grouping. I've got, let's see, there's a 3 in common and a u, so 2u plus 5. And then over here, we've got a negative and what, a 4 in common? 2u plus 5. Oh, good, those match, that works out. So I end up with 3u minus 4, 2u plus 5. Which is awesome. That's the factored form of this thing, but they want the factored form of this thing, so I'll just go back and replace all my u's with what they should have been, y squareds. Right, because that's what eventually I changed, or that's what I changed u for in the first place. And that one was easier. That's my final factored form. I don't even have to reduce that one. That's my final factored form. Okay, so you've seen a lot today. Factoring trinomials comes down to 3 steps. You get your numbers, or sorry, you first identify, you find a times c and b. Find your magic numbers, factor by group, or split it up and factor by grouping. So numbers, split it up, factor by grouping. That works the same for a equal to 1, a not equal to 1, right? Works the exact same way. And then down at the bottom here, you can take some ugly looking things and change them using u sub.